Okay, number 9 is really two different problems here, guys. So, okay, you're getting a BOGO deal right here. We're supposed to find the dimensions of the box, and I wish they used the proper term here. We're talking about a rectangular prism with a square base that has a volume of 12 and then a minimal surface area. So, if I can take you back to geometry here, guys, what we are drawing then is something that looks like, okay, I'm going to draw the front face of this thing first. And then its top is going to basically look like that, and then this, and then that. Okay, gotcha. So we're drawing a rectangular prism, and they're telling us here the base has to be a square. So what's important there, guys? Whatever this dimension here is, I'm going to call that x. This dimension right here has to be the exact same thing. Because the base is a square, those two measurements have to be the same. And then my third variable right here is going to represent the height of that box. I'll go ahead and just call that y. So what's going on in part A? The parameter here, the thing we're dealing with, is that our volume has to be 12. So the volume of any box, such as this, everybody, would be base times width times, or length times width times height, or area of the base times the height. So this would be x times x. So x times x multiplied by y. So x squared y is going to give us the volume of the box, and that has to equal 12. Now in a minute, I'll come back and I'll probably solve that for one of my two variables, but for now, let's move on to step 2. Write an equation for what it is we're trying to optimize. We're looking for the minimal surface area. So we need to come up with a formula for the surface area of this box. Okay, for starters, every prism such as this has two bases, one down here on the bottom of the figure and an identical one up here on the top. And what's the area of each one of those squares? X times x is going to be x squared. Why am I doing this in red? All right, so my surface area is, here we go, x squared on the bottom and an x squared on the top. 2x squared then gives me the area of the two bases, the bottom and the top, added together. Plus, let me switch colors on you guys here. Now, if we take a look at this rectangle on the front of the box, that's got dimensions of x times y. There are 4 of those lateral faces here. So we're going to add to this, guys, a 4xy. That gives us the area of the 4 sides of the box. So this expression right here gives us the surface area of this whole thing. What we're going to do, though, guys, is try to write this in terms of just one variable. So look back up to what I have in red there. X squared y is equal to 12. We need to solve that equation for either x or y, and then substitute that back into the bottom. Well, I definitely think it's going to be easier to solve this equation here for y so that we don't have to do any square rooting here. So y is going to equal a 12 divided by x squared. So there's the parameter, and now I'm going to substitute that in right here. So surface area, which will now just be written as a function of x, is going to be a 2x squared plus 4x, and we'll replace that y with a 12 over x squared. And I'm pretty sure that can be simplified now into 2x squared plus the 4 times 12 is going to be a 48. X divided by x squared is just going to put an x on the bottom. So that's our surface area just as a function of x. Step 3, let's take the derivative now of that function we just came up with, SA prime of x. So the derivative of 2x squared is going to be a 4x. That didn't sound right, but yeah, that's correct. And then plus 48x to the negative first, that derivative will be a minus 48 over x squared. We're going to set that derivative equal to 0 and solve this. So how are we going to do that? I'm going to bring that second term to the right-hand side now and get 4x equals 48 over x squared. I'm going to multiply both sides by x squared and divide by 4. So that's going to give me an x cubed on the left is equal to 48 divided by 4 is 12. So x then is going to be the cube root of 12, and I could go to my calculator right now, I suppose, and try to figure that out, but I think I'm going to leave it there for right now. I actually don't remember if in the solutions right here, I suppose I could look, if I had the answer in radical form or decimal form. My guess is I probably have it in both. But I'm going to leave this one right now as the cube root of 12. Okay, so that takes us here into that one, all right? And then answer the question. What's going on in part 4 right now? Find the dimensions of the box with the square base. So the dimensions then would be this measurement, and this measurement right over here. Now that I'm looking at it, trying to figure out the value of y right here with that in for x, excuse me, is probably going to get a little bit messy. So I do think, after all, I'm going to, sorry about that. I do think I'm going to go to my calculator, if I can find where I put it. Here we go. And I think I'm going to evaluate the cube root of 12. So the cube root of a 12 there, and let me go ahead and come up with that as a decimal, comes out to 2.289. Better write that down before I forget it. All right, so x is equal to 2.289, and then y, right here, guys, would be found by 12 over x squared. So I'm going to type in, let's see here, let me do a stacked fraction here, a 12 over, and I'm going to do my last answer, how do I get that here? There, yeah, last answer squared. Okay, so 12 over x squared, gets us a y value that's identical to our x value of 2.289. That's interesting. So what does that tell us, everybody? 2.289. Those would be our dimensions right there. That's the answer to the question. What that tells me, though, is that regardless of how I drew that problem, the rectangular prism here with a set volume, which in this case is 12, and the minimum possible surface area would actually be a cube. All three of these dimensions end up being exactly the same, and that means that the optimal way to do this problem would be to make it a cube so that the height was exactly the same as the other sides. I'm going to cut this video off, and then I'll come back and make another one here showing you guys how to do part B in just a second.